Alright guys, I'm going to work out the Module 2 review for you, so I'm going to go ahead and start it. So I'm going to work it out like I did the last one, just like I were taking the exam. Alright, so this one, it says, determine visually whether the function is even, odd, or neither even nor odd. Okay, this one, because it's got y-axis symmetry, guys, that makes it an even function, okay? All right, now this one here, this one I believe is actually an odd function, because for it to be an odd function, like if you were to take this piece, or this piece right here, rotate it about the y-axis and then rotate it about the x-axis, it'll line up on this lower piece down here. Okay? And that'll actually be the case for every single piece on here. So if you can rotate one specific arbitrary quadrant about both axes and have it line up on another piece of that function, then it's odd. So this is graph of an odd function. This is a trigonometric function, by the way. All right, and here we're working on transformations. So this is a transformation of our basic x squared function. Okay, and because there's a plus 5 inside the parentheses with an x, that's actually going to shift it to the left 5 places. So I need to pick out, it looks like it's going to be part C. Or choice C, and my basic function is just x to the second power, okay? And then it's going to shift 5 units to the left. Quick, whoops. Well, I didn't graph it. Let me go ahead and graph it here. So I'm going to click on the quadratic tool, okay? Now, since it's shifted to the left, I'm not going to put it right in the center. I'm going to move it to the left 5 units. That's where I'll put, well, actually it doesn't even matter because this dialog box pops up. I thought I was actually going to graph this with my hand, but oops. Oh, just a minute here, guys. Here we go. All right, so I just come over here. This dial, it says horizontal shift, and I'm going to move it to the left 5 units. You can see that it's actually moving the shape of that parabola. Let me just close this and then save it. And then question number 4 here. So this is the same type of question. We've got some transformations going on. This, by the way, is a transformation of that basic x cubed function. Okay, and so because there's a minus 11 inside the parentheses, that's going to shift the graph of x cubed to the right 11 places, and then because there's a negative in front of the function, that's going to reflect it about the x-axis. So I need to pick out the correct choice and shift it to the right 11 units and then reflect it across the x-axis. So it's going to be this one. And our basic function is x to the 3rd power, okay? And then I'm going to go to graph it. I'm going to click on the x cubed tool here. And I'm going to shift it to the right 11 places. There we go. And then to reflect it about the x-axis, you need to click down here. And that'll reflect it, or in other words, turn it upside down. Okay. All right, question 5. Same thing. Looking at this, because there's a square in here, I can tell that this is a transformation of my basic x squared function. And it's going to get shifted to the right 3 places because there's a negative 3. So I'm going to go to the right 3. Then we're going to reflect it across the x-axis because of that negative. And then finally, because of this plus 6 out here, we're going to shift it up 6 units. Okay. All right, number 6 here. This is one I think that I told you I wanted you to list the work on. So to do this one, guys, it says find the zeros of this function. So what that means is we need to set this function equal to 0, and we need to solve it. And those two values of x will be our zeros. They also correspond to the x-intercepts of this function. Alright, so then of course my pen is not going to work. I don't know what's going to happen here lately. It's a connectivity issue, I can tell, because okay, maybe. Alright, well, let me get some paper. It's v squared plus 12v plus 27. So this is number 6, I believe. V squared plus 12v plus 27. Set that equal to 0. Now, I want you to factor this one, okay? This one is factorable, and because it doesn't have a leading coefficient, it's just going to factor v times v, and then my factors of 27 that will add to 12 are going to be 3 and 9. So when you plug those in, you've got it factored. And then when you set each of these factors equal to 0, you're going to find the zeros. Okay, so here you're going to get v is equal to negative 3, and over here v is equal to negative 9. So those are going to be the two zeros. So I'm going to come back and, well, I'm not even going to plug them in. Well, I guess I will. Negative 9, comma, negative 3. Okay, so those would be the zeros. Number 7 here. This one it says find the zeros of the function. Alright, now I can tell by looking at this that this one is not factorable. And so because of that, I'm going to use the quadratic formula. And let's see. Unfortunately, I closed that window, so let's see if I can find it again. Here it is. And this is the one that I prefer anyway. Alright, so it's already in standard form, guys. A is 1, B is 3, and C is negative 7. So 1, 3, and negative 7. Calculate. Okay, so let's come back to the question here. When it says the exact solutions, you're going to separate these with a comma, okay? The exact solutions will be the first two. You'll type in negative 3/2 plus the square root of 37 over 2. And then you'll put a comma, and then you'll type in the negative 3/2 minus the square root of 37 over 2. So those will be your two exact solutions. Now, the approximate solutions rounded to 3 decimal places you're going to get from down here, okay? So this first one rounded to 3 decimal places would be 1.541, and then the second would be negative 4.541. So that's what you would put in for the second part, okay? All right. Let's go to number 8. Find the zeros of this function. Let's see. So again, technically you would take the function, set it equal to 0, and solve it for x. So you'd have a quadratic equation. I'm trying to think, is this one factorable? And it's not. So we'd have to use the quadratic formula again. Okay, so my a is 3, my b is -5, and my c is -13. So 3, -5, and -13. All right, and again, your exact solutions would be 5, 6 plus the square root of 181 over 6, comma, and then you type in the other one. And then these two are your approximate solutions, okay? But it doesn't ask for the approximate, so it's just asking for the two exact solutions. All right, number 9. So, it says use the graph of this function to find the x-intercepts and the solutions of the equation. Okay, so what we have here is this quadratic function. This is its graph. We know that the x-intercepts correspond to the zeros of the equation. So if we were to take it and set it equal to 0 and solve for x, we'll get the x-coordinates of these x-intercepts. So the x-intercepts, if I zoom in here, I can see that the leftmost one here, remember these are points, so the x-coordinate is -1 and the y-coordinate would be 0. So you type in -1, comma 0, and put a comma between your two ordered pairs. And then the other x-intercept is 3, comma 0. Okay, so make sure you type these in correctly. And then the actual solutions, or the zeros themselves, guys, are just those values for x, -1 and 3. So you're just listing them here. You're not writing an ordered pair. Okay, number 10. So I think this is another one where you're going to have to show your work. So this is what I call the ladder problem, okay? So we're going to need some paper for this. So let's look at this. So, draw yourself a little picture if you need to. So the foot of an extension ladder is 9 feet from the wall. So that means this distance is 9 feet, okay? And then here's the ladder. So this is going to make a right triangle. And then it says the height that the ladder reaches on the wall and the length of the ladder are consecutive integers. So if one is x, the other one is going to be x plus 1. That's what consecutive means. And remember, guys, the shorter of the two has to be the leg. It's the hypotenuse that's always your longest side. I'm not sure why I just wrote in there plus 9. Well, this is all we need to know, and then we can take it from here. So I'm going to let x represent the unknown side, and then of course x plus 1, because these are consecutive integers, is going to represent the length of the ladder. Okay. So if you remember your Pythagorean theorem, a squared plus b squared equals c squared. That means if you take the square of the two legs, that should equal the square of the hypotenuse. So the square of the first leg plus the square of the second leg equals the square of the hypotenuse. Well, the square of 9 is 81. The square of x is x squared. And guys, that binomial squared means you've got to write it twice and multiply. Okay, just going to do this real quick. And then finally, plus 1 there. Okay, so these two terms in the middle, x plus x, it's going to give us 2x. So I have x squared plus 2x plus 1. So that's what I'm going to plug in over here. All right. Now, we've got our equation. Now we need to solve it for x. You may be thinking this is a quadratic equation until you start trying to get everything on one side. So if I try to get my x squareds on one side, and I probably want to move the 81 over as well, everything cancels on the left, leaving me with just a 0, but on the right, the x squareds cancel as well. And so all I'm left with is 2x, and then 1 minus 81 is negative 80. And so now this is a linear equation, and we can solve it for x, okay? So we had one like this in the homework. And so we'll be left with 2x is equal to 80. And then if we divide both sides by 2, oops, I'm getting ahead of myself. We're going to have x is equal to 40, okay? Well, 40 is the distance that the ladder reaches on the wall. Let's go back and look at our question to see what it asks. It says the length of the ladder. So the length of the ladder is actually x plus 1, so 40 plus 1, which is 41. Be careful in this one, guys, because lots of times I've seen in the past, students will, once they find the value for x, they just plug it in. They get it wrong. Because x just represents the height that the ladder reaches on the wall, not the actual length of the ladder. All right, so let's look at this one. Here what we've got is the graph of a quadratic function. It's already graphed for us. So we want to find the vertex. The vertex is the center point, so it's going to be 2, 4. Type it in as an ordered pair. And then the axis of symmetry always goes through the vertex, okay? And it always goes through the x-axis at that x-coordinate of the vertex, so 2 in this case. But it's an equation, so you have to type it in there as x equals 2. If you forget that part, you're going to miss it. And then, what is the minimum or maximum value of the function? Well, this function has a minimum, and the minimum itself is the function value, so 4. In this one, we don't have to worry about listing the value of x for which the minimum occurs. Okay. All right, number 12 here. So now, they want us to find the vertex, the axis of symmetry, where the parabola has a maximum or minimum, and find it, and then graph it. Okay, sorry about that. My computer freezes up occasionally. Alright, well, I'm going to copy this over into my notes. The function is x squared minus 4x plus 3. Let me just double check there. Oh, minus 4x plus 3. So I have these signs backwards. Okay, there we go. Alright, well, for the vertex, guys, you've got to remember that formula. The x-coordinate comes from the negative b over 2a. So b in this case is already a negative, so we'll have a negative 4 over 2 times a. A is an understood 1. So on top, that's going to give us a positive 4 over 2, which is 2. Okay, so the x-coordinate of our vertex is 2. Now to find the y-coordinate, you plug the 2 into the function. So you'd have 2 squared plus 4 times 2 plus 3. And if you do all this, I believe you're going to get 15. Yeah, that's right. Okay, so that's the vertex, 2, 15. And that's really all we need to know. Once we know the vertex, guys, we can pretty much determine the rest of that information. All right, so let me type this in, 2, 15, which means the axis of symmetry is going to be x equals 2, because it always corresponds to that x coordinate. And then because the leading coefficient, or a, is a positive number, the parabola opens upward. Okay, so it opens upward and it has a minimum value of 15. That's always the y-coordinate of the vertex. Okay, and then as far as graphing it goes, this one I think you maybe do have to plot the points. So let's see, 2, and then oh wait a minute, I made a mistake. I knew something was wrong because that coordinate system wasn't large enough. 15 is not my y-coordinate because I miscopied part of my equation and my function. That's a negative, okay? And because of that, guys, so you gotta be careful. Because of that, this is going to be a -1, okay? So my vertex would be at 2, -1, so right there. Now, I need a second point, and for that, what you can do is you just plug this function into your calculator if you want. Okay, so it's x squared minus 4x plus 3. I'm going to go to the table, and I can see here, here's another point, -1, 8. You just need one other point. Okay, whoops, unfortunately, well, I can move this point here. Okay, so I'm going to move it to the left, and then move it up 8. It's being really glitchy. Well, let's just cancel this. Okay, 2, -1. That's good. And then -1, and then up 8. Oops. There we go. Got it where I want it now. Okay. Now I'm going to save it. So that should be it. Okay. So just take your time on these. All right, and then number 13 is the same thing. Okay, but we've got a different function. It's -x squared minus 10x minus 27. Okay, so for my vertex, the x-coordinate will be -b over 2a. So a -10 over 2 times a. A is a -1, okay? So get a +10 on top, a -2 on bottom, and that is -5. So that's my x-coordinate. Excuse me. Now to find my y-coordinate, I'm going to plug -5 into my function. So be careful when you're doing this. This negative is already in front of that x squared. So I have a -5 squared minus 10 times -5 minus 27. If you do all this math, I think this is going to become a -25. That'll become a +50. It'll be 25 minus 27, I believe, will be a -2. So I think those are the coordinates of my vertex. -5, -2. So I'm going to type that in. And then the axis of symmetry is just going to be x equals -5. The parabola is going to have a maximum because a here is a negative number, so the parabola is going to be opening downwards. And then the maximum value will actually be -2, the y coordinate, or the function value, okay? And then lastly, to graph it, -5, and down 2, there we go. And then again, I just need one more point. I might graph this in the calculator again real quick. So negative x squared minus 10x minus 27. We'll go to the table. I just need a second ordered pair. Alright, so now I'm seeing one. -4, -3. So here's -4. I'll go down to -3. And that's it. Okay, and you can see this is opening downwards, isn't it? Alright, so that'll be number 13. Alright, number 14. Goodness, it's the same thing. It's x squared minus 10x plus 21. Okay, so again, your x coordinate is going to come from -b over 2a. So negative b is another -10, coincidentally. And then 2 times a, that become a +10 over 2, which is a +5. So my x-coordinate here is a +5. And then to find my y-coordinate, I'm going to plug 5 into that function. Alright, well, if I do this, this will be 25, this will be -50. That would be -25 plus 21, I believe would be -4. So I believe that is where my vertex is, 5, -4. Okay. The parabola is going to open upward because of the sign of a, it's positive. And it's going to have a minimum value of -4. Okay, what about the range? Well, guys, you got to sort of picture it in your head. If the parabola is opening upwards, and this is the lowest point, and it has a y-coordinate of -4, then the range is going to go from -4 upward all the way to +infinity. And you want to use a bracket because you're including the -4, okay? And so, let's see, I need a square bracket. Yep, you can type it there, -4, comma, then I'll get the infinity symbol from my math palette. And then it's asking us about where is the function increasing and decreasing. Okay, so again, think about the orientation of the function. If this is what it looks like, it's increasing on the left-hand side. Remember, these intervals are given with respect to the x-axis. So it starts increasing at this point, whenever x is 5, and then continues to increase onward. So from 5 to +infinity, that's where it's increasing. So 5 to +infinity. And so where is it decreasing? Well, on the other side. So from -infinity all the way up to 5. Okay? So that should be it. Okay, number 15. I think this may be another one that you have to show work for. So we've got this function that models the height of the rocket. It's a function of time. So you can determine how high the rocket's going to be after so many seconds from launch. Okay, so we're going to need to write down this function, negative 16t squared plus 88t plus 5. Okay. And if you look back at the problem, it says how long will it take the rocket to reach its maximum height? And then what is that maximum height? So if you remember what from class, really what it's asking us here is to find the vertex. The y-coordinate will be the maximum height, and the x-coordinate will be the time that it takes to reach its maximum height. Okay, so again, we're using the same formula to find the vertex, except I'm going to use t instead of x. So t will be equal to negative b over 2a, which will be a negative 88 over 2 times negative 16. This will be negative 88 over, that'll be a negative 32. This is one that you're going to want to, it's going to become a positive. It's not going to divide evenly. .75. You can leave it as 2.75 if you want, and I might even do that, 2.75. So this is the time that it takes to reach its maximum height. And then to find the actual height, we need to plug 2.75 into the function. And the function is h of t. H probably for height. So h of 2.75 plus 5. So guys, you just type all this into your calculator. And plus 5. This is going to give us the height. Ooh, 126 feet. Okay. So it takes 2 3/4 seconds for it to reach its maximum height. Alright, it actually shut off because the disk space on my computer was full, so I had to delete some stuff, some previous videos. But the rocket reaches its maximum height at 2.75 seconds, and the maximum height reached by the object was 126 feet. Okay. Alright, question number 16. It says determine the domain of this function. Well, this is a square root function. It's the square root of 2x minus 5. Square root of 2x minus 5. Well, the domain is all the numbers that keep this radicand here 0 or bigger. So to find the domain, we take that radicand and we set it greater than or equal to 0. Okay, and we solve it for x. So I'm going to add 5 to both sides. So I get that 2x would have to be greater than or equal to 5. And then when I divide both sides by 2, I get that x has to be greater than or equal to 5 halves. So that is the domain. It's all the numbers, including 5 halves, and bigger. Okay, so it's got to be choice C. This one is multiple choice. Number 17. So here we are just graphing some of these square root functions. Well, guys, I can pretty much tell you it's not going to be B, C, or D just by looking at this. I think it's going to have to be choice A. But remember, you can graph these in your calculator. B is a linear function. C looks like maybe half of a parabola. D looks like perhaps a square root function, but turned in the wrong direction. So if you're unsure, just, graph these in your calculator. But anyway. All right, so here we're trying to see, where is this function increasing? Well, it's increasing starting at this point onward. And this point has an x coordinate of 3. So from 3 to positive infinity. And by the way, guys, you always use parentheses around these intervals of increasing and decreasing, okay? Now, where is it constant? Well, from this point to this point. So in other words, from negative 3 on the x to negative 3. Or, excuse me, negative 3 to positive 3. Choice C. And then it's decreasing from negative infinity all the way to right here, which is negative 3. So negative infinity to negative 3. Okay, now, this was very similar. Type the intervals in which the function is increasing. Well, I'm going to go from left to right. So the left, this piece right here is increasing. And so I assume that it was always increasing. So I'm going to say that it was always increasing from negative infinity all the way to the x coordinate of this point, which appears to be negative 8. Now, it says you use a comma to separate your answers, so I'm not going to use a union symbol, I'll use a comma. And then it's increasing again right here. Let me zoom in. This stretch, and this stretch goes from negative 3 on the x all the way up here, which is negative 2 on the x. So from negative 3 to negative 2, that's the second interval. Oops. Another parenthesis. So from negative 3 to negative 2. All right, now where is it decreasing? Well, it's just this little segment here. From negative 8 to the x coordinate of this point, which is negative 6. So from negative 8 to negative 6, this function is falling. Negative 8 to negative 6. And then where is it constant? Well, there's a couple intervals right here. So from negative 6 all the way to negative 3. And then again, starting right here at this point, whose x coordinate is negative 2 onward. So from negative 2 to positive infinity. Okay. All right, number 20. The relative maximum. So let's zoom in on this. The relative maximum is right here. So the relative maximum is 1 whenever x is negative 1. Okay? 1 whenever x is negative 1. And then the relative minimum, this is the relative minimum, it's negative 17 whenever x is 5. So negative 17 at x equals 5. All right, and then as far as says here, on which intervals is the function increasing? It's increasing here, so it was always increasing all the way to negative 1, because that's the x coordinate. So from negative infinity to negative 1, and then again from this point onward. So this point has an x coordinate of 5, so from 5 to positive infinity. So it's got to be choice C. And then where is it decreasing? Well, it's decreasing in between those 2 points. So from negative 1 on the x to positive 5 on the x. Okay, so choice A there. The same thing here, guys. This point right here is a relative maximum. And it's the y coordinate is 1, so that's the relative maximum, and it occurs whenever x is 0. So relative maximum of 1 at x equals 0, okay, and then this is our relative minimum. It's a minimum of -3 whenever x is 2. At x equals 2, so it can only be choice C. Alright, so now we got our piecewise function. I think I'm not going to write this out because these two pieces are just linear. But we got to figure out which piece are we going to use for the -3. Well, you got to look at, let me zoom in a little bit. You got to look at what we have over here on the right. We're going to use this top piece for values of x that are less than or equal to 4. Well, -3 fits that category. So I'm going to plug -3 into this piece. So -3 plus 7 is going to be 4. And then whenever x is 4, well, we're using this top piece when x is less than or equal to 4. So I'm still using this top piece. So 4 plus 7 would be 11. And then finally, when x is 7, I'm going to use my second piece because this is for values of x that are strictly greater than 4. So if I plug a 7 in, I'd have 6 minus 7, which is -1. Okay. All right, and then here's another piecewise function here, guys. When x is -7, well, this top piece is for values of x that are less than -3. -7 is less than -3. You gotta be careful. So if I plug -7 in, 2 times -7 is 14 minus 2, or excuse me, 14 minus 6 will be -2. And then -2. -2 is in this second interval right here. So there's no x to plug in for this piece. This is a constant piece. It's just 4. And then for the value 4 itself, where you're going to use this third piece for values of x that are greater than or equal to 4. So you're going to use this third piece. So you plug a 4 in, and 4 plus 3 is 7. And finally, you'll use that last piece for 5 as well. 5 plus 3 is going to be 8. Okay. All right. Okay, so the last couple, these deal with the last things that we covered in class, the difference quotient. And guys, I'm going to give you a hint on this one, just because I don't want to work it all out. This is a linear function. Remember, the difference quotient tells us the slope of a line that goes through any 2 points on the function. Well, because this is a linear function, it doesn't matter what 2 points you pick. The slope will always be the same. And furthermore, this function is in slope-intercept form. And the slope is -10. It's just the number in front of x. So the difference quotient is just going to be -10. You can work it out the long way if you want. And after you cancel everything, you're going to be left with just -10. Okay. All right, number 25. This one we will need to work out. This is a quadratic function. We want to find the difference quotient. Let me rewrite that quadratic function. 5x squared plus 8x plus 9. Okay, and I'm going to go ahead and write out our difference quotient so that we can have it to refer to. And then, of course, it's all over h. All right, so the first part, we've got to plug in the x plus h in for these x's. So if I do that, I have 5 times x plus h squared plus 8 times x plus h plus the 9 minus, and then you've got to keep that second function in parentheses, guys. Remember how crucial this is? And I'll worry about putting it over h here in a minute, okay? But for now, I've got some mechanics to do. The first thing I need to do is actually square that x plus h. So remember, you have to do it like this. X times x is x squared. X times h is xh. H times x is also xh. And h times h is h squared. So these two terms in the middle are going to combine. xh plus xh is 2xh. And we'll recopy everything else. Okay. So now what I'm going to do is I'm going to come back up here. I've got to keep it in parentheses because I'll then have to distribute the 5. And just recopying that. And I guess I'll just go ahead and recopy the rest of it while I'm at it. Yeah. Okay. Now comes the distribution. So now you're going to distribute the 5. So you get 5x squared. You get 10xh. And you'll get 5h squared. Okay. Then I'm going to come over here and distribute the 8. 8 times x is 8x. 8 times h is 8h. You still have the plus 9. And then you're going to distribute your negative. So this will become a negative 5x squared, a negative 8x, and a negative 9. And this is the point, guys, where you should have some major canceling going on. 5x squared minus 5x squared, 8x minus 8x, and 9 minus 9. Okay, that's everything that we can cancel. So what we have left is 10xh plus 5h squared plus 8h. Now, before I put it over the h at the very end, I need to pull an h out of all three of these terms because they all have at least one h. So when I take out that h, remember we call this factoring out the greatest common factor. That'll leave me with just a 10x plus, I'll only have one h left in this term. In the last term, guys, I won't even have an h. Now I can put this over h, and you can see that these h's are going to divide out. And so what we have left right here, the 10x plus 5h plus 8, that is your difference quotient. So that's what you would type in. 10x plus, I forgot it, 5h plus 8. Okay. And that should be it. Of course, I probably missed some of these because I didn't type all the ones in, but you can see, I'm not sure what happened here. Oh, this is the one that I guess I forgot to change or something. Remember that one? Remember, because I made that mistake copying the function. But anyway, just a simple mistake. So take your time, guys, and I hope you do well.